we have our polynomial in this form where we usually put them from the highest exponent power for x and write them down to the lowest power. So for instance, if we had something like f of x equals 7x minus x squared plus 2, we would usually rearrange it as negative x squared plus 7x minus 2. So once we arrange them from the highest power for x, or our variable, down to the lowest, the highest power of our polynomial is called the degree. The term that contains that highest power of our variable is called the leading term of the polynomial. And if we rewrite those powers from highest to lowest, we can get an idea of why this is called the leading term of the polynomial. The coefficient for the leading term is the leading coefficient. So it's just the coefficient in front of the variable that has the highest power. And then finally, the constant term is the one that does not have a variable with it. So we'll be looking at leading terms and degrees and leading coefficient and constant terms in future videos. So usually the stuff that's in the middle, while it does impact the graph and the output values, aren't as important as the leading term and the constant term. So if we just have a function equal a constant that's not equal to 0, then the degree of that constant is 0. So we have like x squared x and then a sub 0 x to the 0. So if our constant's not equal to 0, then our function has a degree of 0 if that's the only thing that's there, if there's no other x's or anything. If we have f of x equals 0, then f has no degree. So we saw in the last video that we could write z of x equals 0 as 0x to the n plus 0x to the n minus 1. So there's really no set number that we would raise our variable to as far as the power is concerned. So it has no degree if it's just f of x equals 0. All right, example 2, find the degree, leading term, leading coefficient, and constant term for the following polynomials. So with problems like these, always first want to make sure that we have this written in order from highest power of x down to the lowest. In this case, it's already done for us, but if we didn't, then we just have to rearrange some stuff. Again, the important one is the leading term and the constant. So if you goof up this order, it's really not going to be all that bad. Our degree is 5 because it's the highest power of x that we have. Our leading term is 4x to the 5th. It's the term that has that highest power of x. The leading coefficient for that leading term is 4. And then our constant term that does not have a variable is negative 5. All right, part B, we have g of x is 12x plus x cubed. So this one we want to write from highest power of x down to the lowest. So let's just first rearrange these terms and get x cubed plus 12x. The degree is 3. The leading term is x cubed, or you can even put 1x cubed if you wanted to. Our leading coefficient is 1, and the constant is 0. We could put a plus 0 at the end, and we'd be good to go. So the constant is 0. The constant of a polynomial is also where it's going to hit the y-axis. Part C, h of x equals 4 minus x over 5. Well, let's break this up as 4/5 x minus 1/5 x, and then rearrange it so it's in order from highest power of x down to lowest. So if we rewrite this in standard form, we get h of x equals negative 1/5 x plus 4/5. So break up the fraction here and then rearrange it from highest power of x down to lowest. Our degree is going to be 1. It's our highest power of x. Our leading term is negative 1/5 x. Our leading coefficient is the negative 1/5, and our constant is 4/5. All right, finally part D, we have p of x equals, oh man, this looks crazy, 2x minus 1 in parentheses cubed times x minus 2 times 3x plus 2. Now, all the other ones, they were not written in this factored form. So looking at this, probably thinking to yourself, do I really have to multiply all this out? If you want to, you can. However, since we're only looking at stuff involving the leading term, which has the highest power of your variable, and the constant term, all the stuff in the middle, which the majority of this multiplication would produce, isn't really going to matter. So what it really amounts to is looking at the first term in each expression. So the 2x, that's going to end up being cubed. all the other stuff in the middle is not really going to matter. And then we have the x in the x minus 2, and then we have the 3x and the 3x plus 2. So we can just focus on those first terms in each of those expressions, and also take into account what power we're raising each of them to. So it's 2x in parentheses that's going to get cubed, not just the x. And then we have some stuff in the middle here, and then looking at the constants, we have -1 is going to get cubed. We're going to multiply that by -2, and also multiply that by +2. So if we actually did want to take the time to multiply this all out, to figure out what the expanded form of it is, eventually, I mean, we would just have, this would be our first leading term result, and this would be our constant term result. So for 2x cubed, where 2x is in parentheses, that's 8x cubed. 2x times 2x times 2x is 8x cubed, times x times 3x. And then -1 cubed is -1, and we would end up multiplying -2 and 2 by it as well. Again, we got all these other terms in the middle that aren't going to matter. So when we multiply out 8x cubed times x times 3x, we get 24x to the 5th, and then -1 times -2 times 2 is +4. And we'd have other stuff in the middle, but that really doesn't matter. So our degree is 5. Our leading term is 24x to the 5th. Our leading coefficient is 24, and then our constant is 4. So, I mean, worst case scenario, if you don't like this explanation up here, my advice would be to actually multiply everything out. You're going to spend a few minutes getting all that done, hopefully to get 24x to the 5th as your leading term and 4 as your constant. Again, the stuff in the middle is not really important. So, but just to save a little bit of time and not have to actually multiply that out, we could just focus on the leading terms and the constants.